Welcome to the Unit 4 homework assignment video. You've heard of the phrase one and done? Well, this homework video is going to be fun and done. Hey. All right, so let's start by looking at this question with my lovely white shirt that I'm wearing right now. A bag contains 5 gold marbles, 9 silver marbles, and 28 marbles. Good morning, October. The rules of the game are as follows. We pick one marble from a bag. If it's gold, we win $4. Silver, you win $3, and it costs $1 to play. What's the expected profit? Okay, so we're going to track this information in a spreadsheet. There's a lot of different ways of doing this, but here is one of them. So let's look at the outcomes, okay? The outcomes are, let's see, gold, silver, and black. Maybe we'll zoom in a little bit so y'all can read it. All right, and we'll look at what are the profits, what are the probabilities. Let's call the profits X. So the probabilities are going to be P of X, the probability of that X. So move these down a little bit. What is the profit if we get gold? Well, if it's gold, we win $4, but that's not our profit because it costs $1 to play. You win $4, you're not really winning $4. You're only coming out $3 ahead. Silver, you win $3, you're only really coming $2 ahead because, you got to pay. Black, you win $0. Of course, you're $1 behind. What are the probabilities? Well, we're only drawing one marble, so we don't have to worry about replacement or compound probabilities. Probability of getting gold, well, there are 5 gold marbles. And how many are there total? I don't know. Let's see. Total, there's going to be, you can type the equal sign here. 5 plus 9 plus 28. And you can do this on Excel, or you can use a regular calculator. There's 42 marbles total. So the chance of winning the gold is just 5 gold out of 42 total. Chance of winning silver is just 9 silver over 42 total. Black, 28 black, 42 total. Now, there's a hotkey. You can press Alt equals, or you can type in the sum command here. Anytime you're working with probabilities and you're using a spreadsheet or something, make sure that it adds up to 100% or 1. Because if these probabilities don't add up to 1, we did something wrong. Okay? Now remember your formula for expected value. Your expected value is just multiply all the x's by the p of x's and add them up. So if we have x times p of x is our own column, click on the equal sign, click on the cell, put an asterisk, click on the other cell, and you can drag it down with this corner here. So each one of these is the product of the two guys next to it, x times p of x. Expected value is just the sum of all the x's times the p of x. Again, Alt equals is that cool little hotkey, or you can type this in manually. You can type in sum, and then just drag like so. We'll find the expected value is about 12 cents. We're going to put our answer like that, about 12 cents, and we're going to hope that MyOpenMath likes my answer, otherwise we're going to have a problem. Great. It'd be a bad sign if it didn't like the professor's answer. And that's the idea here. Let's look at number 5 next. Does this represent a probability distribution? So that was mostly covered at the start. Maybe you forgot about it. There's 2 things that we need for a probability distribution. 1, the probabilities have to add up to 1. 2, the probability can't be negative, and probability can't be more than 1. Kind of the same thing if you tie it in with the first thing. So do these add up to 1? Yes, they do. Are any of these negative? Nope. Are any of these bigger than 100%? Nope. Looks like a probability distribution to me. Great. We did it. All right. Number 7. Baggage fee. So we got an airline charging some fees. It's $25 for the first bag, $35 more for the second. And we have some number of passengers with nothing, some number with 1, some number with 2. And this last part just means we're not going to pay attention to anyone who has more than 2. It's negligible. There's not big enough to make a difference. So what's the average revenue per passenger? Well, now our random variable is no longer profit anymore. Now our random variable is revenue for a single passenger. So what are, to erase all this stuff, what are the outcomes? Well, a passenger could have 0 bags, they could have 1 bag, or they could have 2 bags. And in each case, we need to find what's the revenue for that outcome. We can model it in a spreadsheet like this. So it's $25 in revenue for the first bag. That one's, oh, well, how much revenue do they make from checked bags if they don't check a bag? Well, if you don't check a bag, you don't got to pay for the bag. So there's no revenue. But it is $25 in revenue for that first bag. And the second bag, be careful here. The second bag is $35. But if you're checking 2 bags, what is the revenue for that airline? Well, if you're checking 2 bags, you're paying $25 for the first, $35 for the second. $60 is the revenue here. So watch out for that. Okay, and what's the probability that this happens? Well, it tells us that 54%, 0.54. Or you could really write the percent like this too. That's fine too. It'll take both of them. Kind of weird to use both like I'm doing, but I just want to show you that it works. And 12% were 2 pieces of baggage. Our probabilities add up to 1. That's good. We multiplied all the x's times their p of x, like so. And then we added them all up to find $15.7. So about $15.70. The average revenue from checked baggage. All right. How much revenue should the airline expect for a flight of 20 passengers? Well, here, and it wanted us to round to the nearest cent, each passenger, we're expecting $15.70. So if there's 2 passengers, we'd expect 2 of those $15.70. 3 passengers, we'd expect it 3 times on average. Well, 120 is just going to be, well, 120 passengers, each one we expect to make us $15.17. You could type this in with a regular calculator, but since we have Excel open, this is some good Excel review. $1,884. The revenue for this flight, just from checked baggages, is what we think. We did it. Do 2 more here, 16 and 17. Find the standard deviation of this probability distribution. So I'm going to show 2 things at once with this sort of question. Okay, I want to use the same spreadsheet because this is something that's actually very, very common. So the outcomes, all right, we don't know what x is here. 0, 1, 2. Okay, we need another row. You can add another row, no problem. 3. And then p of x is 0.15, 0.1, 0.3, 0.45. And then remember, standard deviation, not the same as how you find the mean. Standard deviation is the sum of the x minus the mu squared times that probability. Add those all up. That's the variance. Take the square root. So what is x minus mu squared? Well, that's the x value minus the mean, which is the sum of those x times p of x's. We need to square that, so put it in parentheses. Remember, you need those dollar signs around the mean so it doesn't move when you move this formula box. Without the dollar signs, we'd start referencing this cell and then this cell, and that'd be no good. You can also press F4 to give yourself some dollar signs. So x minus mu squared looks like this. Now, what's the issue I made? What's the error? I'm not done yet. One of the errors I made is when I added a row, I forgot to keep this going. Always make sure, drag that bottom corner of the box. Make sure if you ever add or subtract rows, And again, make sure that, oh, we need to make sure to include that bottom row. Probability should add up to 1. Oh, okay. Oh, I don't know what happened to these. Oh, because it's defaulting to a percent. This is 10%. Oh, gosh. 0.1 to 0.3. All right. Tell it to stop worrying about percents. 0.3, 0.45. It adds up to 1. That's great. We're not missing any numbers. We're all referencing the right number. Great. Okay, and now we need x minus mu squared times p of x. You could do this all at once if you wanted. You could just multiply what we found here by the p of x, like so. Now, if we add that all up, it should be the variance. There's a lot of ways of getting here. That should be the variance. So how do we find the standard deviation? Well, standard deviation is just the square root SQRT, parentheses, make sure to include your equal sign, of the variance. You should get about 1.07. Type in that standard deviation, and there we go. Think about mean and standard deviation, what they represent. We said the mean, let's label this, right? The mean, 2.105, that's the average. Should be about 2.05. So yeah, we're going from 0 to 3, and we have a bigger likelihood of getting these bigger numbers, right? These bigger numbers down here have a bigger likelihood of the smaller numbers. A mean of 2 sounds about right. And variance, or the standard deviation being about 1, means that on average, we're within 1 standard deviation away from the mean. So that makes about some sense too. Standard deviation and mean. Mean is also known as expected value. Always have the same units as the problem. So if we found the standard deviation for that baggage problem, the answer would be standard deviation of something dollars. Okay, maybe like $5. Standard deviation will have the same units as the original problem. Number 17, usually get some good questions on number 17, so let's talk about it. The television show, 50 Minutes, has been successful for many years. The show recently had a share of 15. And that apparently means that among the TV sets in use at any moment in time during this show, 15% of them were turned to this show. Seems like a pretty good number. An advertiser wants to verify this 15% share value by conducting its own survey. So maybe the network says, oh yeah, this has a share of 15. And the advertisers are like, well, I'm going to make sure it has a share of 15 before I shell out these big advertising bucks. So they did a pilot survey with only 15 households. Maybe they do a further follow-up survey depending on this study. They're pretty small sample size, 15 households. Pilot survey begins with 15 households have. I feel like the grammar here is a little wrong, but let's not worry about it right now. So we assume that every household, there's 15 total that we're looking at for this sample. Let's assume that every household has the same chance. Okay, what chance do we think these households have? Well, according to our little assumption, we would assume that each household has a 15% chance of watching this, assuming that this claim is correct. We'll talk more about this claim idea in Unit 8 with hypothesis testing. So if all of these 15 households have the same chance, and that chance is 15%, then I get a different version of this problem. I don't like the fact that we have two 15s. Well, fine. Let me do a wrong answer. It even changes the TV show. Okay, great. So share of 20. So there's a 20% chance that they're going to watch it. And then we're going to look at 13 households. Each household has a 20% chance of watching. Okay. Well, we know that this is a binomial distribution because we have 20 households. Each one has the same chance. We go down and say N is 20 households. What chance, or 13 households? What's the chance that each one of them has to be watching it? 0.2. Well, we're asked, what's the probability that none of them are tuned into this show? Well, there's 20. Each one is a 0.2 chance. It's going to be about 5%, 5.5%, 0.055. That's a probability that none of them are watching. We expect about 2 to be watching, right? 20% of 13. But that's our answer here. What's a probability that at least one? Now, there's 2 ways of getting to this second one. We don't actually have to go back to GeoGebra. We can use unit 3. The probability that none are doing it is 5.5%. At least one is the complement of that event, right? None and at least one are opposites in a sense, right? They're the logical pair. So we already know the answer should be 94.5%. But we can do that in GeoGebra. What's the probability that we're at least one? Type that in. We get all these boxes. Notice that these are all the boxes that were not shaded in before. 94.5%. What's the probability that at most one? That's going to be 0 or 1. A couple of ways you can do it. One of the ways you can do it is 0 or 1. You can drag these little arrows. 23.36%. It wants a decimal. If at most one household is tuned into this show, does it appear that the 20% share value is wrong? So is this occurrence unusual? Well, it's kind of unusual, 23%. What counts as unusual? That's a good question. We talk about that in Unit 8. So this is sneaking you into the future. This is stealthily exposing you to future material. What counts as being rare? Really doing hypothesis testing here. This question 17 is Unit 8, the fun section. My favorite unit, honestly. But here it's a little ambiguous, but luckily you have plenty of tries. You could just pick both of them. But the answer is that no, this is not irregular enough. This is not crazy enough. This probability is not crazy enough to disprove our assumption. And we got it all right. Okay. So if the probability of this happening were really, really small, what if this were the probability? That's so incredibly unlikely to have happened that either there's a problem with our data collection or there's a problem with our assumption. And then we would say, yeah, we think the assumption's wrong. But that's in the future. Let me know if you have any questions, and we'll have some more of these. So I'll see you next week. Bye-bye.